Hello, welcome back after half term. I've been signed off by the doctor for the next 3 weeks, so videos is what it'll be, and you will have a cover teacher. So you must come to the lessons. There'll be a video played. It'll still be me, but there'll be another teacher there for help and support, of course. So. Also, on top of that, Wednesday afternoons between 1 and 3, I'll be hanging around on Teams, hoping to speak to one or two of you, and hopefully you'll have a few maths questions for me about things you don't understand or something. So, just a note on this, homework, dreadedly, for the next 3 weeks, can you put your homework on OneNote unless told different by anybody else, and it will be marked by myself or another maths teacher. So homework needs to be on OneNote. For the B group, you're already doing that for Carry On anyway, so it's nothing different for you. But for E and D, you're going to now have to put your homework on OneNote unless you are told otherwise. Anything else I need to say? Probably not, so we better get on with the lesson. You should have this handout. You took these handouts quite a while ago now, so if you could get those ready, I'll give you it's transformations 2. If you were unable or didn't collect a sheet, or you've eaten it over the half term, there may be a few in the box under AS Maths. So it's the AS Maths box on the white shelves. It says it probably says Core AS on a brown box. So if you look in there, don't rummage through it. It'll be on the sort of towards the top. There could be a few extra sheets. There'll also be a spider diagram that we'll be using that you also took before the half term, way before half term. So what are we doing? Well, here's a bit of a recap question first. So if you've got your homeworks ready to hand in, I'm sorry, not handing in, you're going to be scanning them in, as I say, unless told otherwise. So you have to keep your homeworks this week. I'd love to have had them by hand, but unfortunately I can't come in and nobody can bring them to me, so you'll have to put them on OneNote. Sorry about that. And if you can't work it, then ask a friend. And they may help you, and if they can't help you, then Nikki Gale or Minu, see one of those two, and they will assist you on how to put it on OneNote. Right then, from last lesson, a quick recap on your whiteboard. Can you do these? Sketch these graphs on the same axes. And then number 2, sketch those graphs on the same axes. So you're drawing y equals x squared, and you're moving it about 2 ways. Then you're drawing y equals x cubed, if you know what that is. If you don't, you have to fiddle around on your calculator to find out what y equals x cubed looks like, and then draw the transformations of those two. So I'll shut up for a minute. Teacher can pause this, and we'll have the answers. If you can pause, that'd be great. Okay, unpaused, so answers then. So if I'd love to have had one of you up to the front, but not really happening. So here we go. So y equals x squared, this is probably worse than yours. 2 squared is 4, 3 squared is 8. So 2, 4, 3, 8. So that's a normal graph, isn't it? That's a normal graph. That's a, oh my god, that's awful. That's y equals x squared. Then the first transformation, +3, so it should have gone +3 in the y-axis. It would have been the same thing, but up 3. Oh god, wonky, you think I've been drinking. It is milk, promise. And last one, This one, we start with that should be x squared. Now move x squared along. That would look like it's x minus 2, so it would have gone 2 in the positive, wouldn't it? So it would have been here. So it's 4 there and 8 there. So it would have looked like and so on, off the sheet. So that's what you should have got for those. These second ones, if you knew what x cubed looked like, that looks a bit like this. Well, x1 cubed is 1, 2 cubed is 8. You see that in there? Yeah. So, and then same for minus 1 cubed is minus 1. The other thing is minus 8. So, oh gosh, get off. So what it ends up looking like is a bit like, oh, it's gone off, hasn't it? Oh dear. Wonder if that, oh, that's terrible. To get the rubber. Try again. It's a bit like blind on here. So, it's not that. That comes out like that. Well, not quite like that, but and then that one like that. It's a bit like. And so if we transform it, we move it up 3. 1, 2, 3. Draw the same graph. Also at, oh dear, that's a bit of a mess. We move that point up 3. Oh, cat rustling in the bag. And that point up 3. That point up 3. That point down up 3. Yeah, something like. Come on. Not bad. I'm sure yours look a lot better than this one. And if the original graph had moved to the right, wouldn't it? So let's do. So, oh, something like that anyway. Get the idea. Always on quick, because those are terrible graphs. So today we should have this sheet in front of us. Transformations 2. Whether you've got it from the box or where you had it in your folder. So we've got to be able to transform a graph of y equals af of x, transform a graph of y equals a, well, y equals minus f of x, and those other things, and be able to solve transformation rules, sorry, to be able to apply these transformation rules to solving problems. So let's start with the graph of y equals x squared minus 3, and then add the new graph. So if you could colour the new graph on your sheet a different colour, I know it'll be on there, but if you can go over in the next graph with another colour, then that will be the graph of y equals 2x squared minus 6. Here he is. What do we notice here? Alright, what do we notice? So maybe we notice we can produce the graph of that by, ooh, what's that going to be? I wonder. Anybody shout it out? Yeah, it should be doubling. So if you look at like this point here, we doubled 2 to get, doubled minus 2 to get minus 4. So minus 2 doubled is minus 4. So that's doubled. We double the what coordinate? Which coordinate are we doubling? Yep, it's the y of every point on the original graph. You could do that with them all. This one is naught, and it's your double naught, you get naught, so that's why it stays the same. Orange graph. If you pick a point here on the orange graph, where's a good point there? You pick that. That's 1 in, no, it's 2 in the y direction becomes 4 in the y direction. Yeah. So moving on. This has the effect of, you know this one. Can I spell it? Oops, what are you doing? You wrote that's rubbish. Stretching the graph in the vertical direction. If the original graph was y equals f of x, then the translated graph would be written as y equals 2 f of x. In general, the graph of y equals af of x is the graph of y equals f of x stretched in the y-axis by scale factor a. So to perform such a transformation, we multiply the y-coordinate by a. Using the replacement method, which is the one I really hope you'll adopt, because it's the best, in the equation, we'd replace the y with y over a. For this example then, I'll show you how it works. If this is your original graph, remember I'm underlining it now. So replace the y with y over, because we're doubling it, y over the scale factor, which is 2. So this is the original graph with replaced y with y over 2. And then if you just rearrange that, you'll get y equals, times these 2 by 2, 2x squared minus 6. And that's what it's got there. That's our second graph. The replacement method is the one to use. Let's do another. So we've got another one here. Special case when a is minus 1. Ooh, reflection in the x-axis. So it gives it away. So here is the graph of that thing. And then if you want to go over this in a different colour, is the graph of y equals, look at that, minus x squared plus 2x plus 2. And hopefully we can see that's been a reflection in the x-axis. So the graph has been a reflex. Oh no, it's not spelled reflections, must be. I was going to put it with an X, oh dear. Reflection in the x-axis. Each of the y values have been multiplied by minus 1. So if you pick this here, this would be the point. What is it? The point 1, 3. So on this one, it's still going to be the point 1, but it's now minus 3. So it's the y coordinate that's changed. If the original graph is written as y equals f of x, then the translated graph is the transformed graph, I should say, not translated. Transformed graph, I don't like that. I don't like that. Formed graph is y equals minus f of x. In general, the graph y equals minus f of x is the graph of y equals f of x reflected in the x-axis. But with the replacement method, that always works the same way. Because it's the y value that's changed, we replace y with y over minus 1. So in this example, if we replace y, this is our original graph, this orange one here. So if I put y over minus 1, scale factor, equals x squared minus 2x minus 2, just multiply them through by that minus 1, we get y equals minus x squared plus 2x plus 2, which is the blue one. Super. Horizontal stretches. Let's start with the graph, the orange graph, and then add the new graph, the blue one. So can you go over that with a different colour? So what do we notice this time? It's been what? Squashed. Yes. So we can produce the second graph by doing what, do you think? Look at the coordinate here. That one is, we count them, 1, 2, 3, 4. That would be 4, 0. And on the new graph, the transformed graph, it is in fact 2, 0. So it has been, you probably guessed it by now, halved. No, so we can produce a second graph by halving the x coordinate of each of the original points. So this graph has been concertinaed. No, what do you call it? Not condensed, is it? And if you're shouting the right answer, I'll have to cheat and look at my notes. I forgot what word I would have picked there. Oh, compressed. Wait a minute. This has the effect of compression. Maybe you should be writing compression. Compression of compression the graph. That's not right to say. Compressing the graph. Oops. Compressing the graph in the x direction. Big space for the word x, and yeah, never mind. If the original graph was y equals f of x, then the translated graph, because it's in the x-axis, is y equals f of 2x. In general, if the graph is y equals y equals f of ax, it is in fact the graph of y equals f of x being stretched parallel to the x-axis by scale factor 1 over a. So to perform such a translation, multiply the x-coordinates by 1 over a. All very confusing, but not if you use the replacement method. So in the replacement method, you change the x value to x over the scale factor, like we did with the y. So in this example, we would have the original, so y stays the same. We're going to replace the x with x over the scale factor, and the x over the scale factor we're halving. So we're going to replace x with x over a half squared plus 3x over a half minus 4. Now, when you've got something over a half, we've got basically here x divided by a half. Remember, from fraction work, you change that to x, it's change and flip. We change it 2 over 1, which in fact equals 2x, doesn't it? So that is just y equals 2x all squared plus 3 lots of 2x minus 4, which is the graph that we were given in the blue. Replacement method is the way to go, folks. Special case when a is minus 1, it actually becomes a reflection in the y-axis. So here is this graph. Here is a transformed graph. You can see it's a reflection in the y-axis. Which of the coordinates are changing this time? Let's pick a point that we can deal with. I can't really pick that one. Pick that one. Oh, drawing it. So that is 1, 2, 3, minus 3. And what is it up? 1, 2, 3, 4, 5, 6. And that becomes over here 3 along. Oh, it wasn't 3, was it? 1, 2, 3. Oh, it was 3. 1, 2, 3. Yes, it's got to become 1, 2, 3. Yes, so it's 3 along and still 6 up. So the thing that's changed here is the x-coordinate, isn't it? The x-coordinates times by minus 1. So the graph has been a reflection in the y-axis, but it's the x-coordinates that have been multiplied by minus 1. If the original graph was y equals f of x, then we'd say the translated graph is y equals minus f of minus x. In general, the graph of y equals f of minus x is the graph of y equals f of x reflected in the y-axis. Replacement method, the way to go. Here we'd replace, because it's the x's that are changing, we replace the x with x over scale factor, which is minus 1. So with the original graph, y equals, we put in brackets, x over minus 1 power 3 plus 4 lots of x over minus 1 all squared minus 3. Okay, so minus 1, that means minus 1 times minus 1 times minus 1 gives us a minus 1, doesn't it? So we get y equals minus x to the 3. Minus 1 all squared is just 1, isn't it? So that's just really 4 lots of x squared, and then take 3, which is in fact the graph we were given here, because if you'd done the same multiplying that one, we get y equals minus x3 plus 4x squared minus 3. That's what the blue one is. Super. So that's the cases for reflecting. So let's have a go at these little beasts. We've got to use the sketches to transform the graph of y equals root x. Good old rooty x. Now, does anybody know what the graph of y equals root x looks like? You could put it on your calculator, but it'll only ever draw half the graph because it only draws functions, does your graph. The graph of y equals root x, you have to go back to basics, put numbers in. So if we have the number 4, root 4, it can be either 2 or minus 2. And some of the nice ones I can do. Root of 2 would be plus root 2 or minus root 2. So it's like a graph like that it ends up with. So we've got to make the transformation of this thing. So what I think of is, if we've got here part A, so what we could have got here, well, if you take the 3 down there, it could have been y over 3 equals root x. So what the transformation has been, what it has been is a stretch in y-axis by scale factor 3. So if I change this point here, stretching y by scale factor 3, so 2 now becomes a 6, so that'll be way up there. Let's go in, oh, it's 2, 4, oh, we're way up there. Way down there. But this one, 0, the y-axis is on 0, that's 0, 0. If you stretch that one, scale factor 3, 0 times 3 is still 0, so still going through there. So really it's a monster graph. Way up there. Way down there. Alright, next one. What colour should we have? Black. B. Looking at that one, ooh, it's the 2 stuck to the x, but I have to write that as y equals, now replacement methods, it has to be something x over something, so that's got to be x over a half, hasn't it? And then the 2 would pop to the top. Ooh, that's like enough at x. X over a half. In fact, I might write that again because it's badly written, isn't it? Try again. It's done rubber. X over a half. That feels better. Bring the 2 up, so that's exactly what it's got there. So this is in fact a stretch by scale factor a half in x direction. So basically the x coordinate is halved. So if we half the x coordinate, which is 4, half that, you get 2, don't you? So it'd be 2 along, 2 up. Like that one, I'll just replace that one. That one should have been, because we times it by 3, hadn't we? That was 3 times, oh, it's 4. It would have been 4, 6. Anyway, this one, 2, 2, 2, 2 there. And basically it carries on like that. Well, whatever point you've got, oh, I'll not guess it. I'll just draw them. That's it. So it's been stretched in the x by scale factor of, I might do another point because 0 stays the same, doesn't it? At the moment this was 6, oh no, 6 about 2.5, isn't it? So if we half the x, that would be 3 about 2.5. So it's going up like that. So it's very similar. Ooh, to the other one. I don't know if they mean. Oh gosh, what's that monster? Right, there we go. Let's hover on fast from that because that's a bit of a disastrous graph. Right, each of the sketches, thankfully sketches, not perfect drawings, reflections are applied to this thing. Find the equation of each. Rightio. If we were to draw that graph, you could draw it on your calculator. So check answers on your graphic calculator. If you were to draw that one, you get that. You might want to have a whirl with that now. It's graph mode and type in x squared plus 2x and then draw it. Right, then it says we've got to find the new equation if we had to stretch 4 units in the x direction. 4 units in the x direction, so we replace x by x over 4 because it's a stretch. Okay, so that's basically it. If you want to multiply that out, that will give you y equals 1 over 4 squared is 16. And 2 over 4 is just a half, isn't it? So that's our answer. Part B. Stretch of 2 units in the y direction. So easy peasy. Replace y with y over 2. So original graph, y over 2 equals x squared plus 2x, and you might rather see that more friendly as y equals, take the 2 over to the other side, 2x squared plus 4x. And then final one, C, will have a different colour. C, you can draw these graphs on here if you wanted, but I'll make a mess, so I won't bother. Reflect the graph in the y-axis. So it's in the y-axis. When reflecting the y-axis, remember, so this is reflecting the y, so that reflect that point, which might be 310. Let's call that 310. That would reflect to minus 310. It's reflected in the y-axis. So what's changing is the x coordinate, not the y, the x. So replace x with x over minus 1. So y equals x over minus 1 all squared plus 2x, oh, I'll put the 2 there, 2 over 2 lots of x over minus 1. If you sort that out, minus 1 squared is just 1, so that's just x squared, and that affects that, doesn't it? So it becomes minus 2x. So that's our other equation. I will draw that one. That one will look like, ooh, dipping down there. Oh, nice. Right, is there any more? I don't think so. A bit of a summary. Oh no, there's one on the whiteboard for you. Surprise. Right, have a go at this one. It's a bit different because it's applying to y equals 3 to the x, if that cons you out. But please use replacement method. See if you can write the answers to those 3. Please pause, teacher, while you have a go. And hold your boards up. Teacher may know. Okay, unpaused. Here come the answers. First one was stretching the x direction by 3, so replace x with x over 3, which could also be written as that thing there, the third root of 3 to the x, but the original one there, 3 to the x over 3. That's okay. B is replace y with 4. You can write it like that. And C, reflecting the x-axis, remember that changes the y, so it's y over minus 1. And just ends up as that. Spot on if you got them. If you didn't, can you see why you didn't? As I say, you didn't need to get those like the cube root. You could have left it as 3 to the power x over 3 would be fine. Right. Here's the summary. So this is what we did last week and what we've done this week. So y was f of x plus c is a translation by the vector naught c. If we're using the replacement method when we're doing such a thing, because it's the y, we'd replace the y. So replace y with y minus 3. When you've got such a thing here as a translation by the vector minus d0, we'd be replacing this time the x with x minus minus d, so x minus negative d, which is in fact, isn't it, x plus 4. I always said 4. X plus d. I'll change pen. When we're doing a stretch parallel to the y-axis by scale factor p, so here, y-axis is the clue, so replace y with y over p. If we're doing a stretch parallel to the x-axis, oh, here goes a cat. Bubble! Bubble, come here, darling. Bubble, come on. Sorry about this. Children, come on, what's wrong with you? Never mind. Right, so if we're doing a stretch parallel to the x-axis by scale factor, rather noisy, 1 over p, you replace x with x over 1 over p cube, sorry, which is in fact just qp, isn't it? Qx, all right, use some p. Reflection in the x-axis, remember that means that the y coordinates change, so replace y with y over minus 1. And reflection in the y-axis means the x has changed, to replace x with x over minus 1. So please stick to the replacement method, it just makes things clearer. Right, complete spider puzzle. You should have a spider puzzle. Have a go at that. So if that's you haven't got it on A3, you've got it on A2, so it's this thing. I don't know if I can hold it up, so you know what sheet I'm talking about. Filled mine in, but that's a spider that you should have got somewhere for transformations. It's not the one we filled in, the last one, it's a new one. So you should have that in your thing, your bank of sheets. And if you haven't, there are a few spares, I think, in that box with the lesson notes. So please fill in that. It says on the top transformations. And it starts with this, starting with y equals root x, y equals 2 to the x, and y equals 1 over x squared. There it is, actually. So it's that sheet that we're after. If I just do one with you, what it's asking you to do then, if we take this one at the top, translate. Oh, we've done translations in the last lesson. Oh, we do them again. Translation one. So we'd have to just write for this one. If you translate that graph, it's in the y-axis, isn't it? So we'd replace -3. So you replace the y with y. Oh, goodness me. Y take -3. So y take away -3 equals root x. So you might have jotted that on your whiteboard and then write y plus 3 equals root x, and then perhaps y equals root x take 3. That will be that. We've also got to squash on these other ones. That one, replacing y with, I'm going to do not write y take 3, I'm going to replace y with y plus 3. So the other one would be y plus 3 equals that. Take it over, y equals x take 3. That's that one. And then the third one we're taking over. Really got to squash these on, haven't you? Let's do some of it on the whiteboards. That one, again, y plus 3 equals 1 over x squared. So you take 3 over and it's y equals 1 over x squared. Take 3, and so on. So that's just one branch. Can you do it for all branches? So if a teacher could please pause this video while I sort out a manic cat, and oh, I better not, and you have a go at this. So please pause. Silly thing. And whoops. Now unpaused, hopefully. And here come the answers, she says. There we go. That's the 3 answers for each one. Have a stare, see if you've got them right. Okay, we'll move on a bit now to function notation and an unknown curve. So here we have it. Transforming an unknown curve. The diagram shows, no it doesn't, there. The diagram shows a sketch of the graph y equals f of x. The curve passes through the point 0, the origin. We'll have to draw it ourselves, I think. 0 passes through the point 2, minus 1. That's the A. And the point 6 along for up. That's B. Right, so let me draw what it's meant to look like. So it's a bit of a curve, so it's coming down like this. I don't know what it's called. It could be called Bertie. It's meant to be smooth, by the way. So it's not meant to be like a woo. If I can erase that wobbly one, it looks like I'm not drinking milk. Oh, off it's gone. Put that back. There we go. Right, so we've got to draw these new sketches. That's our f of x. We've got to draw them, I think we have here. Draw the new one. So if you look at this one, it must have been a replacement with y over 2, wasn't it? So really it's been a stretch by scale factor 2 in y direction. And you do that, but it's very hard. What you have to do is use these points. So you change the y at 0, 0. So changing the y coordinate, stretch it by 2. So 0 times 2 is still 0, 0. So still going through 0, 0. Here one, that one's the point 2 minus 1. So stretch the y by 2. So it will go through 2 minus 2, won't it? And then that was the 0.64, so stretch the y by 2, becomes 8, 4. Condensed graph anyway, so it probably looks the same. 8, 4. So our graph's still the same shape. It should look a little bit more stretched. Lovely. Next one, let's move on. Okay, let's do the next one and put these others up because I've ended up drawing on them otherwise. So, this one, what's happened? Well, they've replaced x with, because it always take, isn't it? X take -2. So that one is a translation. I'll write it as vector form of -2, 0. So the graph has moved to the left, hasn't it, too? So the old 0, 0 becomes -2, 0. The old 2 minus 1 becomes 0 minus 1. And the old 6, 4 becomes 4, 4. Only the x has been moved too. So, ooh, same sort of shape. So, right, greeny. This one, they've replaced, take him up there. That's a bit tricky, isn't it? If you took that up there, you get 4y equals f of x. So they must have replaced the y with y over, because you need it over 1/4, mustn't they? So it has been, in fact, a stretch by scale factor 1/4 in y direction. So 0, 0 stays 0, 0. But this one, 2 along -1, so it's the y that's changing, becomes still 2 along, but times that -1 by 1/4, you get -1/4, so it's here. Go there. So that's 2 minus 1/4. And the other one was 6, 4, wasn't it? So the y coordinate now, if we times a y coordinate by 1/4, we get 1, don't we? So this is a funny little curve. 6, 1. So this one looks like that. Would actually be a little bit less steep there, but there we go. Right, last one. What was this one? Oh, it's here. To get that there, we're going to have to replace, write it like that, minus y equals f of x. So we've replaced y with y over -1, haven't we? If I try it again. So it is affecting the y coordinate, so it's going to be a reflection. Which axis? If it's going to affect the y, y is jumping from plus to minus. It's a reflection in the x-axis. So 0, 0 stays 0, 0. But to reflect, this was 2 minus 1, so it becomes 2, 1. This one was 6, 4, so it becomes 6 minus 4. So you graph this time something like that. And you'd label the points to show you knew what you were doing, in case you just in case your graph was a bit dodgy, like mine always is. Right, so that's those. So it says do exercise 5C, page 74, 1 to 10. So you can stop and do those, but let's just do a few whiteboard things first. A few guesses here, no guesses, of course not guesses. Multiple choice, so you only choose constructively the answer. So whiteboards at the ready. Which one's the answer to this? That graph has gone to that graph. Look at the coordinates. Which do you think it is? Well, look, if you match with the teacher, I'm sure they're joining in. It was, in fact, D. Move 2 to the right. Next one. Boards up. What do you think this one is? It's stretching the y, so y's been replaced with y over stretches 2, so y 2, so then the 2 will pop up. So it is, in fact, hope you've got it, C. Next one. Have a look. Put your answer on the board, A, B, C, or D. See if you match with the teacher. So it's the x coordinates that have changed this time. See, they've been multiplied by 2. So it is, in fact, B, isn't it? Multiplied by 2, so you divide by x over 2. Next one. Oh, Buster. Put your answers on the boards. Hold them up. Reflection in the y-axis, so it's the x coordinates change, so we're going to change the x. So it is, in fact, A. Next one. Boards up. If you match the teacher, it is the y-axis that seems to have moved up to. So replace y with y take 2. Then when you take the 2 over, it becomes, yep, plus 2. So it's that one. A. Last one, silly cat. Look what's happened. It's the x coordinates are changing. They have been halved, haven't they? So we're replacing x with x over a half. And that then gives us, if you've got this one, B. So when you put x over a half, it becomes 2x. So there we have that. Done. Right. I think that's, oh, there's another one. Bonus one. What's happened here? Oh. So it is the y coordinates changed. Put answers on your boards. Place y with y over minus 1. Then sweep the minus 1 up. You would have got A. Yes, well done. I think that is it now. Yep, stop. Right, have a go at that exercise and see how you get on with those questions. We could end the lesson here. If the teacher wants, that's enough. If there's anybody wanting an extension at the end, there is a question that follows from this, or you may prefer to watch it at all. The teacher would kindly stop and let you have a go at those exercises there. Very happy for you to end the lesson here, but if you want to show up this question also, you could leave it on the next slide paused for anybody who wanted to have a go at an extension or an exam question. Here it is, but I'd rather you were doing that exercise to start with, that exercise on the top there. But at the end, if anybody wants to have a go, please do this. So please pause now, teacher, haven't paused before, and just flash the answers up to this at last 2 minutes if anybody's actually had a go at it. But prefer you have a play with those exercises there from the textbook. Textbooks are at the front as always. Come and grab one between two and see how you get on. Okay, bye from me. See you next time. And remember, get that homework on OneNote. Thank you. Bye-bye. Unpause right at the end of the lesson. Here are the answers for that. You want to peruse that, see what the answers were.